this one here. Okay, so now our first derivative, we're going to bring that 5 down to the front and subtract 1 times the derivative of what's inside. Okay, so that's just 5 times 2x plus 6 to the 4th times the derivative of 2x plus 6 is 2, and that just becomes 0. So we're left there. So our h prime of x is equal to, once we multiply those, 10 times 2x plus 6 to the 4th. Okay. So our h prime of x, well, double prime of x, which is just the derivative of our first derivative. So that's just the derivative of 10 times 2x plus 6 to the 4th. Straighten that up a little. Okay, so we can go ahead and just factor out our 10. Okay, so we bring our 4 down to the front. 2x plus 6, and we subtract 1 times the derivative of what's inside. Okay, so this ends up being, could have did that, but we'll wait and multiply all those at the end. 4 times 2x plus 6 to the 3rd times derivative of 2x minus 6 is 2. If we go ahead and multiply all 3 of those, we end up with 80 times 2x plus 6 to the 3rd. All right, any questions on that one? All right. Okay, so we're going to do one more like the second one. And then we're going to compare the two. Okay. So if we're given h of x equals 6x squared plus 4 to the 6th, find the second derivative. All right. So for this one, start off like we did before. We find the first derivative. So we bring our 6 down to the front. 6x squared plus 4, and we subtract 1 times the derivative of what's inside. Okay, so that equals 6 times 6x squared plus 4 to the 5th power times the derivative of 6x squared. If we bring down our 2, 6 times 2 is 12. So we have 12x. That becomes 0, so we end it right there. Okay, so we know our h prime of x is equal to, multiply that, that just becomes 72x times 6x squared plus 4 to the 5th. Okay, so just the fact that that x is here means you have to use the product rule. Okay, so we know our second derivative, which is just the derivative of the first. Okay, so we know that's going to equal the first times the derivative of the second plus the second times the derivative of the first. Okay, so we can go ahead and simplify that. So we have our first, which doesn't change. Derivative of the second is 5. We bring that 5 down. And keep forgetting to use the bracket so we won't have as many parentheses in there. So we have 5 times 6x squared plus 4, and we subtract 1, times the derivative of what's inside. Okay, so remember, that's just that first term. Plus 6x squared plus 4 to the fifth times the derivative of 72x is just 72. Okay, so we go ahead and simplify this. We have 72x times 5 times 6x squared plus 4 to the fourth times the derivative of 6x squared. Bring that down, it becomes 12x. Derivative of 4 is just 0, so that stays. Plus 6x squared plus 4 to the fifth power times 72. Okay, so just like before, we can factor out 72 and 6x squared plus 4 to the fourth power. Okay, so if we factor out our 72, and, well, actually we can go ahead and cross that out here once we do that. And 6x squared plus 4 to the fourth power, that disappears here, and that just goes to the first power. That leaves us with, here is 5 times 12x, which gives us 60x, plus that x is squared. Can't forget about that one, which, as you can see, it's really easy to do. So you have 60x squared plus 6x squared plus 4 to the first power is just 6x squared plus 4. Okay, so we can go ahead and just combine those two. So that's equals 72 times 6x squared plus 4 to the fourth times 66x squared plus 4. Okay, so if we actually look at these two side by side, let me zoom this out a little bit. Oh, we can't zoom it out. Okay, so if we look at those side by side, you can kind of see where the steps are really similar. Okay, find your first derivative the same way. Both of them have an x. Okay, then you can see as you go through the right steps, if you reach this step and you can't factor out you might as well say your derivative here, and these, you know, somewhere along the line you probably made an error, because you should be able to factor those out. And one way you can tell you're going to have to do the product rule from the very beginning to find the second derivative, if this is squared or higher. So if the inside is squared or higher, you're going to have to end up doing the product rule. Because if you notice from the first one, that's just to the power of x. So you didn't have to do product rule there. But if you do end up with a squared or higher on the inside, find a second derivative, you would have to do the product rule. All right. So any questions on that one? All right. Okay, so let's say, for example, actually, I have to go to the trig definitions before we run out of time. And make sure we get those in. Okay. So this is the chain rule for trig definitions. All right, so just remembering all of our trig definitions from before. Okay, so we know the derivative of sine is cosine. The derivative cosine is negative sine. Say the derivative, I'll move that over. I don't know why I didn't start over there in the first place. Derivative of tangent is secant squared. Okay. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. Okay, so those are all the ones we had from before. Okay, so let's say if you have, instead of some x in there, let's say you have some function of x, x squared plus 2, 3x to the third plus 5x plus 4, any function of x. Okay, let's say if you have the derivative sine of gx, and that's just going to equal cosine of gx times the derivative of what's inside. Okay, and the rest of them are just like that. It's the exact same rule, but you're just going to multiply it by the derivative of whatever's inside. So derivative of cosine of some g of x is going to equal negative sine of g of x times whatever that g prime of x is. Okay. Derivative of tangent is just going to equal secant squared of whatever that g of x is times your g prime of x. Okay. Derivative of cotangent of your g of x is going to equal negative cosecant squared of g of x times your g prime of x. Same thing with secant. G of x. So it's secant of g of x, tangent of g of x times g prime of x, and cosecant is the same way. We'll move that up some. That's negative cosecant of g of x times cotangent of g of x times g prime of x. Okay, so in every case, you're just going to multiply it by the derivative of whatever is inside. Alright, so let's say, for example, okay, if we want to find the derivative of, let's say for problem A, h of x equals sine of 2x. Say for problem B, let's say g of x is equal to cosine of x minus 1. And let's say for C, f of x equals tangent of 3x. Okay, so for A, of course you're going to use the derivative of sine of gx equals cosine of gx times g prime of x. Alright, so we know our h prime of x, well, should have been h of x in there. Let me make sure that's the same there to avoid confusion. Alright, so our h prime of x is going to equal cosine of 2x times the derivative of 2x. Okay, so that's going to equal cosine of 2x times 2. Okay, and remember, you don't multiply it by this because these are two separate factors. So this just becomes 2 cosine of 2x. That's why I like using the brackets as much as possible. It kind of prevents little mistakes like that because it's real easy if you have it like that to kind of distribute the 2. But cosine 4x would be wrong. Okay, so we do the same thing for B. Okay, so we're going to use derivative cosine, in this case it is g of x, equals negative sine of g of x times the derivative of g of x. Alright, so we know we're going to have our h prime of x is going to equal negative sine of x minus 1 times the derivative of x minus 1. Okay, so you have negative sine of x minus 1 times 1, which just stays the same. All right, any questions on that one? All right. And for C, of course, we're going to use the derivative tangent of f of x equals secant squared of f of x times the derivative of what's inside. Okay, so we're going to have our f prime of x is going to equal secant squared of 3x times the derivative of 3x. Okay, so that's just going to equal secant squared of 3x times 3, which gives us 3 secant squared of 3x. Any questions on that one? Okay. Nope, no one's still writing. All right. Make sure you have enough time. Okay. So let's say if you have the derivative of an absolute value. Let's say find the derivative of g of x equals the absolute value of 2x minus 3. Okay. Now before we can start on this one, okay, you have to remember that absolute value in this case of g of x is always positive. Okay. So that means, let's say if we make g of x, let's say we make that equal u, equals absolute value of u, then that means, since it's always positive, we can actually rewrite it as the square root of u squared. Because remember, the square and the square root will cancel out. You just end up with an absolute value of u, especially since you have a even index. Okay. So g prime of u, well actually this, if you write it as u squared to the 1/2, if we bring down our exponent, 1/2 times u squared to the negative 1/2 once we subtract 1, remember that's times the derivative of u squared. Okay, so our g prime of u is going to equal 1/2 u squared to the negative 1/2 times 2u. Okay. Now in this case, the 2 u's would cancel out. So you end up with g prime of u equaling, we might as well put that down the denominator, u over u squared to the 1/2, which we already know is equal to absolute value of u. Okay. Oh, 2u times u prime, where is it? That's what I forgot, that part. Okay. So remember, you have derivative of this is 2u times the derivative of whatever u is. So that's u prime. So this should actually be times u prime. And you won't have to remember all these steps. Okay.
So where you got u prime from again?
Oh, because when you have the derivative with respect to x, you have 2u times the derivative of whatever u is. Remember the derivative of whatever's in the inside? That's what we have here. So g prime of u is actually equal to u over absolute value of u times u prime, which is really all you have to remember for absolute values. Chain rule for absolute values. Okay, so if we want to solve this one, so g prime of x, remember that's u over absolute value of u times u prime. What if we let u equals 2x minus 3? u prime, or derivative of u, is just 2. So that means this just equals 2x minus 3 over absolute value of 2x minus 3 times 2. Or just 2 times 2x minus 3 over absolute value of 2x minus 3. Okay, so you don't have to remember all of the explanation if you don't want to. All right, so any questions on that one? All right, so I'm just going to do one more example, and actually that would be it. And that's when you have the derivative of, I guess you could say, 2 composite derivatives. Oh, you want still writing? Okay. Okay, so let's say, for example, let's say composition of 3 functions. Okay, so instead of the regular let's say h of x equals f of g of x, let's say if we have, say, k of x equals h of f of g of x. We have a function inside of a function inside of a function. Okay. So the derivative of that, k prime of x, will just equal h prime of f of g of x times f prime of g of x times g prime of x. Okay, so really you just apply the chain rule twice. All right, so let's say, for example, if you have this one, if you're given k of x is equal to 4th cosine of 7x squared plus 1, you want to find k prime of x. Oop, that's getting ready to shut off.